we get to hear Susan Cole, who will present her work in Massachusetts and in Harvard Law School, Massachusetts being an example of a state that has really embraced many of these issues and has, to use Nancy's terms, really put things into action legislatively so that many of the approaches to trauma-sensitive institutions that we'll hear about today are actually occurring in those schools. So we'll have a practitioner who helped to make it happen talk about how it was made to happen. And then in the third panel in the afternoon, we'll have a number of advocates talking about the different advocacy approaches that they have taken in different institutions to bring some sort of constructive relief, to fashion remedies, to talk about advocacy itself and the various ways that it can be formulated and some of the problems that they've encountered along the way. And then finally, if you're still here, I'm going to try to blow it up in the afternoon and present a little bit of my work as a way to engage you all in a curated discussion of pretty much everything that's happened before. You'll get opportunities to speak to each panel, but this will be an opportunity to sort of blow up the broader issues of intervention and prevention in the context of some of the work on structural inequality. And I'll try to bait you into some positions, and we'll see if we can't end on a lively note. And then my dear friend and another one of the great lieutenants of the directions of Rutgers University, Newark, Dr. Bonnie Vasey will close us out. Okay, so 3 minutes and we'll be back with the first panel. Thank you.
So you must get our mail.
Yeah. We still get your phone. We're in sequence. But we still serve it basics and so we still get your, actually we got a phone trying to do yours.
I'm running late with the bills that are fine.
I have no idea. They just asked Newark no, we're going through. Actually, our administrative assistant is the girl here.
Oh, that is
Kelly. She probably gets the phone Victoria practices.
And I also preside over the research program. So it's a community court program. So I have alternatives.
Okay, it's good to meet you too. Years ago, I went this around. Well, I know her as Sage, but you know her as, and, you know, yeah, so Milton's daughter. And so I met you through her.
I went and bought one and I was like, that's it. That's it. Now we gotta get in it.
Now, okay. I did, yes. And we were in sisterhood together, and like, she is my friend. Yes. So I just, years ago, met you years ago. Yeah. Of course, I remember you, because you were memorable. Oh, okay. That's still No, like major. Yeah.
Okay, folks, we're ready. We're ready to begin. Please take your seats. Please take all the seats. We don't have a lot of provision for overflow, but we do have some. If we can't fit everybody, we actually have chairs here, the old Perry Mason courtroom-looking chairs in the front, although you won't get the benefit of a table. And then there's the jury box. It's always fun. I also want to make sure that you all see the Wi-Fi address on, and I just want to warn you that it's going to ask you for it about every 10 minutes. So we won't feel bad if you look down at your laptop while we're speaking to to put that back in, but since there will be slides, you may want to jot that down on the side, just in case you are prompted to enter it again. And so, I think we're ready to begin.
Hi, everyone. So, as was stated, my name is Dr. Alexandra Margevich, and I similarly have a background in social psychology, particularly implicit social cognition. So I'll be moderating this first panel on the making of trauma, definitions and genealogies. So again, during this panel, 3 experts from the fields of psychiatry, social epidemiology, and clinical psychology will explain, as the program notes, the sources of trauma, what trauma looks like through the lifeline, and long-term effects of trauma, in order to reveal how the nuances in understanding trauma affect system responses to trauma. And a brief note on logistics, I ask that you please hold your questions to the end of our 3 speakers, and each speaker will present for approximately 15 to 20 minutes, and after the last speaker, I will open up questions to the audience. And our first speaker is Dr. Royce Lee. Dr. Royce Lee is an associate professor of psychiatry and behavioral neuroscience at the University of Chicago. He's affiliated with multiple hospitals in the Chicago, Illinois area, including Mercy Hospital and Medical Center and the University of Chicago Medical Center. He received his medical degree from Northwestern University Feinberg School of Medicine and has been a practicing psychiatrist for about 17 years. As an expert in psychiatry and neurology, his research focuses on the effects of early life trauma on the neurobiology of emotion, as well as the neurobiology of personality disorders. Today, he will be presenting his talk on these matters, and I'm just going to pull up his slides now, and I'd like you all to please introduce or welcome Dr. Lee.
Hi. Thanks for having me here. I'm really excited to be here. I was doubly excited because here in Chicago we are starting to think about these problems at our home university with the opening of our surgical trauma center, which is sort of undoing decades of spatial trauma in the sense that we lacked a level 1 trauma center. Do I push here? Clicker, okay. So my purpose here will be to review the injury of trauma, and I think my colleagues will talk about other aspects of trauma. So I'm going to zero in on what we understand about trauma's effects on the brain. And first we'll talk about epigenetics and neuroplasticity, and I'll talk about these in broad terms. We'll talk about trauma and stress reactivity, which is where most of the empirical research has been in this area. And then we'll talk about something I'm very interested in, which is mistrust that arises as a consequence of trauma and is sometimes neglected in the empirical work. A colleague of mine at the University of Chicago has been studying primate abuse for the first half of his career. And his findings are really quite astonishing. And when I first saw them, I really had an aha moment about what we're looking at when we look at human trauma. With the attachment system comes, all sorts of benefits. Everybody in the room is aware of these things. But the attachment system is complicated, and just because it's there and genetically encoded doesn't mean it's always going to work correctly. And so we see this in primates too, non-human primates, where the prevalence of serious abuse and neglect really map nicely onto what we see in people, suggesting that with advances in the attachment neurobiology come certain prices. So it turns out that primate mothers will abuse their children at about a 5 to 10% rate. Sometimes it leads to infant death, not always. These mothers tend to be pretty good mothers, astonishingly. So outside of the episodes of abuse, they're very caring. And in terms of their overall emotional behavior with the rest of the group, they're mostly intact. But when you look at certain indicators like stress hormone levels, these abusive mothers are clearly stressed out. They have high levels of CRH. Oops, wrong pointer. Good. All right. Sorry about that. The abusive mothers have higher levels of corticotropin-releasing hormone, indicating that there is some relationship between the stress the mother is experiencing and then a maternal behavior. Okay. We're going to now talk about what changes with trauma and what is it about the brain and the body that are susceptible to these outside influences. And I would roughly categorize these two kinds of change as neuroplasticity on the one hand and epigenetics on the other. And so we'll briefly review this. The neuroplasticity is an NMDA receptor-mediated process whereby neurons that wire together fire together. And there's a picture of Thomas Hebbs, a psychologist who first coined this phrase. And the NMDA receptor is a neurotransmitter receptor in your brain. It's in the synapse. Sorry about that. It's kind of hard to see, but it's this green thing here. When a neurotransmitter binds to it, what happens is that a signal is sent to the DNA inside the cell, and the DNA does its work, like working with Lego blocks. It creates more neurotransmitters that go to the surface of the cell, so that the next time this cell gets a signal, the response is amplified. And here it's hard to see, but you'll see a general trend of the waviness increasing. This is from a seminal paper by Lomo in 1966, showing a process called long-term potentiation. In this study, a stimulus delivered to the hippocampus of a rodent becomes potentiated when the signal is repeated. And then here we have a picture showing what happens to the synapse. This is mRNA binding, which is a downstream signal from the DNA to help create the proteins. We tend to think of the brain as a jumble of wires and things like that. These synapses, though, they're very dynamic. They're constantly changing shape. Even when you're sitting still, they're getting smaller and bigger, and with experience, they rapidly either disappear or grow back. So the brain is constantly pulling in information and constantly changing. This will be kind of hard to look at, but I'll guide you through it. When I think of, in my work with seriously emotionally disturbed adults with histories of childhood trauma, I think of their problems falling into three general categories. The first category would be what I call representation, and that is how does the brain hold information? Another term might be working memory. We think of remembering a phone number. 7 digits is what people can hold in their mind. That process is mediated by excitatory neurotransmitters and inhibitory neurotransmitters interlocked in a circuit. And this basic circuit repeats all over the brain. So we have different brain structures, but this essential circuit is repeated again and again. And there are interconnections between this excitatory and inhibitory neurotransmitter. These connections are very plastic, and they change like the synapses we saw a picture of. They're changing constantly. When in a normal zone of functioning, we're able to think clearly, we're able to concentrate. When you push the system very hard, it starts to break down. At the extreme end, we have things like psychosis, where the information that the brain is processing essentially becomes corrupted. When we're healthy, which involves eating well, sleeping, not being overly anxious, the system can process information. The second general category of problems, we would call that stress reactivity, anxiety, depression, the emotional system. What I'm showing you here is a picture of something we call fear conditioning, whereby a neutral tone associated with a shock will lead to rapid escalation of a fear response. When you present the tone without a shock, you see a gradual elimination of the fear response. What's happening in the upward slope is that the emotional areas of the brain are going through long-term potentiation, that process I mentioned before, and we see an enhancement of a fear response. What's going on in the second half, when we have the stimulus without the tone, is that the hippocampus and frontal lobes are now taking over and sending an inhibitory signal to the emotional areas of the brain. That general model encompasses most of the clinical things we see in the emotional sphere. So when we think of post-traumatic stress disorder, fear responses that are out of control depression or anger, we can think generally of this model applying. And again, it's a very plastic process. It involves the person just constantly taking in information. When I talk to medical students, I tell them that this process is a little bit like TiVo, which kind of dates me. But it's not something we control. And so when we think of the traumatized youth that we're concerned about, they're just taking it all in, right? They don't want to take it in, or they don't need to take it in. But it's all being absorbed, this constant learning. You can imagine their synapses constantly changing. There's no way this information doesn't get to them, right? And finally, the third thing that can go awry is, we could call it generally empathy. There are different kinds of empathy. There's an emotional empathy, which involves imitation and sympathy. But very importantly, there's a kind of cognitive empathy that involves manipulating information in your mind. Another way to term that would be perspective taking. That's the ability to think in your mind of what another person is thinking about. It's very hard to do. You've got to want to do it. It takes effort. You have to learn how to do it, and you have to model it after people that you're around. It is something that can go seriously wrong as a consequence of trauma, and I think of that as a neuroplastic learning process. Okay, that being said, this is a busy slide. I'll just give you the punchline. These folks analyze data from two very large longitudinal data sets looking at single event traumas and adult IQ. There were strong relationships between these two variables, but after accounting for baseline differences, most of these differences were diminished, and this is the difference between the green lines and the orange lines. Most of these measures are basically IQ. And so these findings are somewhat controversial, but I bring this slide up just to remind the audience that trauma, you could say it damages the brain, but that's not quite right. A trauma doesn't make people less intelligent. Right, so these children who are taking in their information, they're learning. Their IQ is not decreasing. They're just learning the wrong stuff, right? They're getting these messages in. Their basic ability to focus, to concentrate, to process information is intact. And that makes sense. When we think of why would we have a system to learn, it wouldn't make sense if trauma made us unable to process information. Okay, this is one question that comes up is, well, how do we know when we talk to people, they tell us about the trauma, how do we know that's what they experienced versus what their biases? We approached this question with the twin study, and in essence what we found was that subjective reports of trauma have genetic contributions, but also environmental contributions in roughly equal thirds. And so what that means to me is when I'm sitting with a patient and they're telling me about their experience, you have to be open-minded about what you're hearing, but there's reasons to validate what they're telling you about. There's also reasons to think, where are they coming from, and what is it about them that causes them to experience something a certain way. Okay, that's interesting. This slide, the brain disappeared. So imagine a roughly round-shaped thing here. Oh boy. And the hypothalamus is releasing corticotropin-releasing hormone, or CRH. We call that the master stress hormone. The pituitary then releases something called ACTH. That stimulates the adrenal gland to release cortisol, and most people are familiar with cortisol as the peripheral stress hormone that's released. Here we have stress, this lightning bar. That stress has to be processed by the brain, and so that's a lot of circuitry, a lot of interpretation of data. And so this slide is basically giving you an overview of the stress response in relation to a stressor. So we have the brain that processes it, and remember that's a very neuroplastic process. And then we have the adrenal glands ultimately sending out a signal to the rest of the body and back to the brain. There's a long story about cortisol and trauma. In essence, this is a fact, that traumatic, stressful experiences increase the cortisol response. There are some important nuances, though, that now decades of research have hammered out. In young children, we see high cortisol in response to stress and trauma. But as the individual gets older, and time from the index trauma passes, we see a reversal of the response. And the cortisol levels actually decrease in response to stress. So for those of you who are looking at the literature, you'll see different findings. And this may help you to interpret what you're seeing. So initially in kids, you see this burst of cortisol. So a stressed out child will usually have a high cortisol. But the adults I see don't. They actually have very low cortisol levels. And so that has important implications for things like inflammation and other processes related to cortisol. Okay, I'm going to give you a very brief primer on epigenetics. This is a kind of a hot area that we don't fully understand, but it does answer an important question of why would the highly neuroplastic brain in some ways have a rigid response, right? So we're talking about lasting effects. What makes something lasting other than our determination, to keep our good habits and things like that? So one possible answer has come from this area of epigenetics. In the genome, groups of molecules can be methylated. To be methylated means a carbon atom is bound to the gene. This methylation process will silence that gene and prevent it from being transcribed. And so it turns out that we not only have our genes to determine how we express ourselves biologically, but you can think of this as a whole nother system controlling that genetic information. And the addition and subtraction of these methylated residues is very stable. It's not permanent, and it can be reversed, but it's hard to reverse it. Thank you. Work by Michael Meany has showed that in a rodent model, when you disrupt parental care, you silence the genes that control the stress response. Here we have a picture of pups where their maternal care was disrupted, and you see a lot of black dots. Those black dots represent methylated portions of the DNA. He's gone on to replicate that study in both mouse in human studies. And so now we think that this is a fact of biology, that these early life experiences can change the way our DNA is expressed in a lasting way. The lasting effects of that, let's skip forward here. Here we have a measure of parental care, and on the y-axis, levels of the central stress hormone, corticotropin-releasing hormone. In essence, what we see is in response to childhood trauma, the brain has high levels of stress hormones. In childhood, in the periphery, we have high levels of cortisol. In adulthood, those cortisol levels start to drop off and become very low. We don't yet understand why that happens, but we think that's one of the lasting effects of stress and trauma. In my last few minutes, then I'm going to skip forward to some other work that we've been doing. So we generally think a lot about cortisol and its effects. The cortisol is a hormone that goes into your cell, and it binds to your DNA, and it changes how your DNA is transcribed. So when we think about what is that doing, that means cortisol, the stress hormone, is a signal to change how your DNA produces proteins. But the stress system also goes up back into the brain, and that's one question I've been very interested in. To do that, we looked at several different kinds of data. One kind of data is measuring levels of the stress hormone in the brain. When you give this stress hormone to monkeys, what we see is they transform from a social individual to a highly anxious individual, and that anxiety is only apparent in a social context. These primates aren't nervous about food or things like that. What they're nervous about is what's going to happen to them in the social group. When we look in humans at the correlative trauma and high central stress hormones, we see something that we don't usually talk about. It's called paranoid personality disorder. Now, I wouldn't suggest that we all go out and look for paranoid personality disorder. I think it's a waste of time. There's no drugs for it, and therapy is hard. But what's interesting about this is a relatively neglected aspect of trauma. So these are individuals, they're not psychotic, they're not talking about UFOs or aliens. What they're talking about is that they really can't sit in any relationships comfortably. They can't sit with their parents, with their own children, with their teachers. You know, with me, it's difficult. Systems, they don't trust the systems, and it's a lasting effect. I'm not sure if this is stress hormones or the neuroplastic processes that I described earlier, but it is a thing, and I think it's often neglected, and something to think about when we think about how we're going to intervene in these individuals who have been traumatized. The bottom line is they don't trust us. In my opinion, there's a biological aspect to it, but there are also other learning-related aspects to that. Yes, skip forward in the interest of time. So to recap, we have the brain, which is meant for change. That's why we have such a complicated brain. We could get by with much less, to drink our coffee in the morning, commute, go to work, answer some emails, and come home. But because of the curveballs nature sends us, we have an organ that allows us to change. Interestingly, extreme stress, we would call trauma, affects the way the brain changes. We're still trying to catch up and understand what's happening here, but the general message is that mechanism we have to change, trauma does something to it, and in some people it might be helpful, and other people not so helpful. I think I'll stop here. Thank you.
Thank you, Dr. Lee, for making the neurobiology of trauma a little more digestible for some of us. Next up, we have Dr. Natalie Slopen, whose talk I think will build very nicely on this one. She's an assistant professor of epidemiology and biostatistics at the University of Maryland School of Public Health. She obtained her doctorate of science in social epidemiology at the Harvard School of Public Health, and her postdoctoral fellowship training at the Center on the Developing Child at Harvard University. Her impressive body of research focuses on social influences on health, health disparities, and psychological and biological mechanisms through which childhood experiences get under the skin to increase risk for later chronic diseases. So please help me in welcoming Dr. Slopen.
Hi, I want to thank you for having me here today. It's a huge honor to get to speak to people outside of my discipline and be able to share this work with you, and hope you can take it places to make a difference in this community and beyond. So we're going to get started now with my presentation. I'm going to focus on three main objectives today. I have three messages that I hope you'll be able to take home that represent different aspects of my work. First, I want to talk about the epidemiology of childhood trauma and adversity, with the main take-home being that these adversities are very, very common among children in the United States and are not distributed equally across individuals. The second is that childhood trauma has a lasting impact across the life course. And third, I'm going to spend some time talking about possibilities for social interventions that may be able to interrupt the disruption for lifelong achievement and health outcomes. So I'll get started with a discussion about the epidemiology. In order to do that, I just wanted to spend a couple of minutes talking about what we mean by this word trauma and how we may use it over the course of today and in this general body of research. So a lot of people subscribe to the DSM-5 definition of trauma, which states that trauma is exposure to actual or threatened death, serious injury, or sexual violation. And this can occur via direct exposure or victimization to oneself. It could be witnessing this event yourself, or even hearing about it happening to a close friend or family member or loved one. However, within the field of child development, and often within conversations talking about childhood trauma more generally, we may expand this definition to include other aspects that are highly stressful and highly upsetting to children that may not necessarily threaten death per se. So people at the Center on the Developing Child, like Jack Shonkoff, invented this taxonomy of stress, because we all do experience stress, most days of our lives, right? But there's such things as positive stress, which is the normal day-to-day stressors that we all experience that aren't necessarily part of unhealthy processes and are in fact healthy for us to expand our lives. Then there's tolerable stress, which are difficult things that we can move past. But what we're really talking about today, and this research that I'll be presenting falls into this category, is this concept of toxic stress. And what we mean by this is prolonged activation of our stress response systems in a way that will disrupt healthy physiological processes. And part of this definition states that this is happening outside of the context of support. Okay? So sometimes toxic stressors may happen, but it won't have this long-lasting influence on health, provided that these happen within some context of support. Okay? But we're talking about those experiences without the absence of mechanisms to keep individuals healthy. So epidemiologists set out to provide information about the prevalence or incidence of these sorts of traumas and exposures. And this is something that's not that easy to do, and that's why you see across the literature varying estimates that often vary dramatically across studies. But I'm presenting to you data from what I view as some relatively good recent sources. So this first slide is showing you prevalence of lifetime adverse or traumatic experiences in children coming from the National Survey of Children's Health. This is data from the 2011-2012 survey. And you see here that these negative